Thanks to the MongoDB team who've really worked hard to put this together. It's really fantastic. Let's have some fun before we start. This is a pirate box. There's treasure in here. It's locked with a key. So think about how you might break into this box, and then at the end of the session, we'll come back and see if anybody figures out how to get in that box. Okay, gonna jump in here. I think I'm gonna jump in here. Oops, there we go. Before I start, I just want to tell you an experience I had in San Francisco. I was at the booth, at our booth, and a woman came up and was asking about our security solutions, and she had a name tag, and underneath the tag it said scientist. So my brain went and said, data scientist, right? No, she was a biologist doing amazing genomic research, really incredible stuff. And she had deployed MongoDB as a way to collect that data and analyze that data. And it just, to me, it just spoke volumes about how easy it is to use MongoDB and how powerful it is when someone can do that. I mean, I come from legacy database days, and it took weeks, months to design databases, and she was doing that. So I had an eye-opening moment about MongoDB at that point. Then we turned around and we talked about compliance, genomic data, sensitive data, encryption, GDPR. So she had a little eye-opening moment at that point about really protecting that data and making sure it was under proper control. So let's jump in. I'm going to talk about key management for MongoDB Enterprise or Advanced, and why it's important, and some of the key concepts. So not really a technical session, just going to talk a little bit about encryption and key management, so you get kind of based in some security aspects. Information, we're going to talk about compliance a little bit and how that comes to play. We're storing a lot of interesting stuff in MongoDB, aren't we? Talk about key management best practices. Then, for those of you who are technical, I'm going to show you what it's like to launch key management with MongoDB, how really easy it is. And I just can't say enough about how well the MongoDB team has thought out encryption and the related key management requirement around encryption. So they've done a really good job, and I'll talk about that some more. Then also I'm providing a resource guide here. So things that I talk about, we might go by a little bit fast, but at the end there's a resource guide. My understanding is that this will be available online after the conference, and so it's a resource for you. Okay, we all know that data breaches happen. Equifax, a lot of folks have suffered data breaches. In fact, we are all subject to this kind of activity. We think it ought to be getting better. It's not. I wake up every year, I go, oh, is it getting better? No, it's getting worse. So it's really important that we pay attention to what sensitive data we're storing in MongoDB and what's considered sensitive data. So we call this personally identifiable information, or in the medical segment, we call it protected health information. GDPR defines personal data for data subjects. And this is, it's all important to know, and we need to know what we're putting into MongoDB. It's so easy to put things into MongoDB, isn't it? It's incredible. So I have a database background. I can't believe what people are doing with MongoDB. So, but paying attention to what kind of data we're putting in there is really important, so that you don't get crosswise with compliance regulations like GDPR. Every country, every geographic area has a different set of compliance regulations. PCI, of course, covers the globe. If you're taking credit cards and putting information into MongoDB, you may be covered by PCI. But there are just a raft of a large number of compliance regulations that we have to meet. GDPR is one of the most concerning regulations right now. How many of you have had somebody ask you about GDPR? Yes, absolutely. Every day I'm dealing with this question. Article 32 is a section that deals with the security of data. It's very generalized. GDPR deals with things in a somewhat of a general nature. Unlike PCI. PCI says you will encrypt a credit card. No questions about it. If you're not, you're out of compliance. GDPR says you have to analyze your data. You have to understand it, and you have to apply appropriate technical controls. So in most cases, when you have sensitive data in your MongoDB database, encryption is going to be the safest place to be to meet compliance regulations. So you won't find any place where it says in the GDPR, and part of my job is to understand compliance regulations. I read the whole thing and the secondary material, but you won't find it. You won't find a mandate. Okay. But hint number one: treat it as a mandate. If you're putting sensitive data in MongoDB, encrypt it. Okay, why is key management important? Encryption key management. So we say, in our company, we say, well, encryption is the hardest part of security. People often leave it to last. The hardest part of encryption is key management. So the secret that we have to protect is not the encryption algorithm, it's the key used to encrypt the data and to decrypt it. So it's really important to get a good key management strategy in place. There's a lot of published information in standards bodies and from NIST, for example, and ISO about the importance of key management. So it's really, when you do encryption, it's important to do that. So MongoDB gives us two places to store our key. Where are they? On the disk next to the database in the clear, or on a key manager. Okay. And so I think you know probably the best place that you want to be storing your keys. We don't want to, when we walk out of the door in the morning, we don't tape our key to the door just to make it easy to find when we get home. Okay. We secure that key and we keep it with us. That's the whole point of a key management system. I know that people worry a little bit about encryption. How many people have said to themselves, what's it going to do to me if I implement encryption? Yes, that is probably the number one concern I hear personally from people when they're thinking about employing encryption, whether it's in SQL Server or Oracle or MongoDB or any place else. Well, there's some good news here. MongoDB has stepped up to the bar. They've implemented encryption in the MongoDB Enterprise Edition, and they've done a good job at this. They've optimized that encryption. Yes, there will be a performance impact, but it's really very manageable. And MongoDB publishes guidelines about different implementations of MongoDB and the impacts of encryption. So there's a real good, I think, profile here. I think anybody running MongoDB databases can feel comfortable deploying encryption, testing it themselves, understanding the performance impacts, but it's very, very manageable. And again, I think the team has done a great job of owning that. So the encryption for MongoDB is in MongoDB itself. You don't need a third-party product underneath MongoDB to do the encryption. It's in the database. So that's really, I think, a fantastic way to approach it. They step up to that performance metric. They've optimized it, and I think they've done a good job. Other impacts really might be backup and restore operations. This is not so much of a problem for MongoDB because you're replicating. And a lot of times people depend on replicated images for their backup. But if you do back up to virtual tape or to the cloud or anyplace else, when the database is encrypted, you can expect an additional amount of time and space to do that backup. And high availability comes into play. So again, MongoDB does a lot for us as a database for high availability with our replication sets. They've taken care of that. But that also applies to key management. So if you are running a replication set in a remote region and you have a problem in your primary set, the key management solution you deploy had better be available in that other set. So good key management systems will allow you to deploy real-time mirroring of keys to a secondary key server. This is completely manageable within the MongoDB context. So again, high availability among key managers, important things to look at. I'm going to make some reference to our own because you all know we have a key management solution that works with MongoDB. But I think this is a fairly generalized information. I think this can be helpful across the board looking at key management solutions. But mirroring keys in real time, if you have a key created in a primary key manager, you want it to be in the secondary one pretty quick. So real-time mirroring of keys and access policies are important. Again, key mirroring is nothing is in total real time, even replication sets. I mean, we're moving over the wire and things like that. But real-time mirroring in the key management solution is critical for high availability. Some best practices. So I love the fact that MongoDB is providing education, online education. We're taking advantage of that. And they're providing some guidance around best practices. And that includes some best practices around security. So I really encourage you to go for the resources that MongoDB is making available. Take a look at them. They're very digestible. Well, I say that as a security person, but maybe you'll find something different. But it's a very digestible information, and it's in the resources section here. So if you haven't seen that before, you can find it in the resources. Key management best practices. Well, you want to generate strong keys. You do not want to be generating a key for MongoDB that is just a string of characters like a password. Those are amazingly weak from a cryptographic sense, from a key management sense. A key management system will provably build you strong encryption keys. And in this case, with MongoDB, 256-bit AES encryption keys are what are used. Key management systems will use accepted and standard-based encryption, ensure that keys are securely backed up, mirrored. We've never had a customer lose a key. Everybody worries a little bit about that. If you lose your key, you lose your data. But key management systems are really designed to help protect against that kind of instance. And in the 10 years we've had systems in a variety of customers, no one's ever lost a key. But of course, key managers, in addition to creating keys and storing them and protecting them, have to give them up. They have to give them up to MongoDB so that it can encrypt the database. So there's a lot of work in key management systems to secure the connection from MongoDB to the key manager when they're needed. Okay, so one more set of kudos to MongoDB. Again, I told you we work with a lot of database vendors. We do encryption across a broad set of technologies. MongoDB, out of the box, adopted an industry standard for talking to key managers. So it's called the Key Management Interoperability Protocol, or KMIP. That is the mechanism by which MongoDB implemented the conversation to a key manager. So when you implement encryption and you define your key manager, you're going to be implementing that over an industry standard. That is so important. Standards win over time. We know that proprietary implementations eventually fall out in the face of good industry standards, and KMIP is the standard for talking to key managers. So MongoDB did a great thing by just out of the box implementing the KMIP standard for talking to a key manager. So it, in the long run, reduces cost. In the long run, gives you the flexibility to move from one cloud platform to another, to move from in-house to the cloud, to do hybrid arrangements. KMIP is an important standard, and we just love to see them implement that in MongoDB. Okay, MongoDB, the developers, stepped up to doing encryption. So they built right in the database using 256-bit AES encryption. Anybody in here a cryptographer? No? Yes? No? Good. Really, two modes of encryption supported there, not really important. Both of them are strong AES encryption based on industry standards. If you're from the EU zone, you might think of it as Rheindahl encryption. We call it AES here, Advanced Encryption Standards. It's a well-accepted standard for a number of years worldwide. And so if you have to meet compliance regulations in some environments, like governmental agencies, standard encryption is really important, and MongoDB did that. And when you deploy a key manager that's also based on standards, you're really in a great position to address those markets. Okay, what's our experience with MongoDB? So KMIP came forward in a release, I think it was 3.2 if I'm not mistaken, of MongoDB. And so our dev team looked at that and liked MongoDB, and they said, hey, they're supporting KMIP. can we do we work with that? And so more than a couple of years ago now, we fired up a little skunkworks project and quickly certified internally that we supported MongoDB. And we started going to market and talking to MongoDB customers. Last year, we certified formally with MongoDB, both on Intel architecture and on IBM's Power architecture. So we are certified our Key Manager for both of those platforms. And some of you are probably looking at the new Power 9 processors and the real performance they bring to the table. So we certified on both those platforms end of last year. In January, we joined by invitation, joined the Partner Advisory Council. So we've just been enjoying a really wonderful relationship with MongoDB. And I hope you're enjoying that too. I mean, it's been a great company to work with. Listening has gone both ways between us. So we have a very strong relationship with MongoDB. Let's talk a little bit about some advanced topics. Again, I'm gonna actually get it at the end here, show you what it looks like to spin up a Key Manager and connect it with MongoDB. And we're not going to go online to do that because we don't have a whole lot of time. But we're going to actually show you what that looks like. So those of you who are technical, hold your horses. We'll get there in a little bit. The MongoDB, when you implement encryption in the database, you must implement it on an empty database. So you can't, if you have an existing database, you can't just start encryption on that database. So what you have to do is spin up an empty database, start encryption, get it active, and then pipe your data into it. So there are some really easy ways to do this kind of migration. There are utilities from MongoDB. I am not a MongoDB expert, so I'm going to leave it to you all to work on that. But that's the path to getting your data encrypted, is to spin up an empty database and then move data into it. You can do that from an existing enterprise version or a community edition. So I know a lot of folks who are migrating from community to enterprise to get the encryption capability. Really straightforward process. And even if you have a large MongoDB database, that can be very efficient. Next, if you're going to implement encryption and key management, again, you got to talk about high availability. You want key managers to be redundant. So normally that's done just through the setup process, and I'm going to show you a little bit of a menu where we define that in our Key Manager. But you probably want at least a pair, possibly more, key managers that are mirroring keys in real time. You want them ready to go, up, hot. If there's a problem and you have to switch over to a failover, a replica set, you want your Key Manager to be there too. Right now, you can define a single Key Manager in the MongoDB configuration file. There's a security section where it defines a KMIP key server. So for failover, we usually deploy a load balancer in front of the Key Manager. So if there's a problem reaching a Key Manager, then the load balancer takes over and redirects traffic to a backup Key Manager. I think we'll see in the future some enhancements there to support multiple Key Manager definitions, but it's an easily manageable issue in today's environment. Also, what we're discovering is that people are running hybrid environments. Some people are running in the cloud, some are running in Atlas, some are running MongoDB in-house. There's a mix of applications, and then applications that are feeding data to MongoDB are all over the place too. So really, hybrid environments are really important. Being able to deploy key management as a cloud instance, as a VMware instance, as a hardware security module, really important. Anybody here from the financial industry? Yeah, okay. I don't know why, but big banks seem to love hardware, but having an HSM available to support your key management needs in MongoDB is really important. So hybrid environments are important. So keep in mind that you may be mirroring keys from the cloud to on-premise. You may be running MongoDB in the cloud. You want your keys on-premise. We have one customer who does not trust Amazon for some reason. They run their application in Amazon Web Services, and they run their Key Manager in Azure. Okay, so they actually do cloud to cloud. Yes, okay, what we said is you want to do that? It's fine, it's okay. But actually, mixed cloud platforms and hybrid environments are becoming far more common. And just know that this is very achievable with today's technology. It is actually more the rule than the exception. So we have customers today mirroring keys out of cloud on-premise, either into a VMware instance of a key manager or an HSM. So all of this can be easily achieved. And again, you have to hark back to the fact that MongoDB used this KMIP interface, the industry standard. It gives us so much flexibility in where we put stuff. I saw in the keynote, talking about, one of the points that Dave made was, well, we can run anything anywhere. You should be able to run your key manager anywhere too, right? That's a corollary of that if you're doing security. Okay, I tend to motor mouth. I'm going to move along here. I want to show you what it looks like to launch a key manager and hook it up with MongoDB. And I'm going to summarize here. There are a few intermediate steps, but you're going to get the basic idea. So our key manager is in AWS. I'm just using this as an example. I log into my EC2 console. I select the AWS Marketplace to launch. I search for Townsend Security. Yep, there we are. And it asks me a few questions. If you've launched an instance in Amazon, this is all very familiar to you. I just select the default tier. I'm grabbing a specific set of keys. I'm not going to use my general keys. I'm going to ask for a specific set of keys to launch this instance. If we're implementing a segregation of duties, I can now separate access to the key manager from access to the data. So in this case, I'm asking Amazon to give me a unique set of keys for this instance. I download them, and off we go, and it launches. It takes just a few seconds to get an active instance running in EC2. You can see it running here. We've got an internal and an external IP address in the AWS instance. I now have an active key manager in AWS. So now I have to do a little bit of configuration on the key manager. So I SSH into there using my special keys. I SSH in, get a little menu, initialize AKM. That's our key manager. So I'm just going to, there are a lot of options on here, but I'm just going to walk you through that. So I take that option. Notice I get a choice to initialize a primary or a secondary. So you start your primary first. If you're launching a secondary, which can be in a completely different region, then you can take that option and they'll connect with each other. They'll ask you for some credentials and they'll connect and they'll fully set up a mirrored set of key managers right in AWS. So I take the option for primary and it starts asking me some questions. Questions like 2-character code for your country, full name of your state or province. Sound familiar? Yeah, we're building a PKI, okay, right inside the key manager. The last field there is enter a unique name for this AKM, and that's important. In this case, I'm using AKM MongoDB. That's going to be a name that glues MongoDB to my key manager. You'll see that in just a minute. Okay, I press enter to go. The PKI gets generated. Guess what? We build you automatically a unique set of keys for you, ready to go, ready to use with MongoDB. And that just takes a few seconds. Then I launch our administrative console, little GUI application, again, authenticated with PKI infrastructure, so you have to be authorized to do that. And I list the keys, and if you can see that on the right, I've got a set of keys built for this. So AES 256-bit key has been created, and it's called AES 256. Okay, I just built a key manager in a few seconds with keys. Okay, 10 years ago, this was a 6-week process. Now it's a few seconds, dialogue. And I'm going to download credentials that I need to use with MongoDB. So MongoDB is going to use certificates from the key manager to authenticate itself to the key manager when I fire it up. Okay, I got those. So that wasn't hard. It's not like eating your broccoli. So let's go over on the MongoDB side. And again, I'm going to simplify this. You all are MongoDB experts. You know what it takes to launch MongoDB and get it up and running. I'm just going to show you a few aspects about that in terms of encryption. So I take and I create a directory on the MongoDB instance. This happens to be a Linux instance. And I'm going to use that to store the credentials, those certificates that I downloaded from the key manager. I'm going to put them there. You can use FileZilla or SCP or whatever you transfer that you like. I'm going to change the ownership on them and grant MongoDB access to them. Those are my credentials. Those are the credentials that MongoDB is going to use for that. Then the next thing I have to do is I have to tell MongoDB where to find the key manager. So I'm going to update the etc host file again on Linux. And I'm going to put in that AKM MongoDB name. See where it says server name under the configuration? This is MongoD.conf file for you Linux folks. And there's the name, that AKM MongoDB. I put that name in the etc host file, and I'm putting it in the configuration for MongoDB. So I've created a connection between MongoDB and the key manager. This is how it works. The security section in the MongoD.conf file is commented by default, so you're going to uncomment that, and then you're going to put in the information. So there's the path to the certificate file that we just put up there. There's a client, and then there's a key identifier. The key identifier is a key name in KMIP terms. It's called a KMIP object ID. It's the name of a key. It's not a key. It's not the key. It's just the name of the key. So MongoDB will use that name to retrieve the actual key and to unlock the MongoDB database when it starts. Okay, boom, start MongoDB. Again, we're on an empty database right now, but that's all it took. So this is the easiest, fastest implementation I've ever seen on any database, and we support a lot of them. So just want to show you how, from a developer point of view, it's not complicated, it's not scary, it's not going to trip you up, it's really straightforward. By the way, we publish, and every key management vendor does, we publish user guides, and there's a MongoDB quick start guide on our document website. Walks you through a little bit more detail here in terms of how to get to this point, but this is really a demonstration of how really easy it is to do this. Okay. After the last class, people asked me a lot of questions about encryption of data in MongoDB. They're saying, can I encrypt data at the application layer before I put it into MongoDB? Yes, you can. So with our key manager, and this is true for all of them, we provide a lot of software development kits, SDKs. So if you're a Java programmer, a .NET programmer, Python, we have software development kits that you can integrate with your applications, encrypt that data before it goes into MongoDB. That's okay. You can actually do that. You can actually, at that level, assign different encryption keys to different data or to different people. Okay, so you get a lot of flexibility if you do this at the application layer. Whoops, that's not past our crystal ball. Okay, as I look out into the future, what do I see in the crystal ball? And I'll just kind of share with you my perceptions. So we've been in the security space for almost 2 decades. Yep, 2 decades. So I have never experienced compliance regulations getting easier. Have you ever seen a compliance regulation say, oh, let's do less security? No. Never. It's always getting harder and harder, and more encryption and more security is a part of that. So I expect that GDPR will make its way really into a lot of regulations across the planet. So we're going to see that. We're going to probably have a need for more encryption keys. I don't have any inside information here, but it wouldn't surprise me at all if we got field level encryption from the MongoDB development team at some point. So I'm just saying, in the general evolution of databases and encryption technologies, we may find that happening someday. And I would fully expect that the key management strategy that's in place today will be in place, the same strategy will be in place tomorrow. So MongoDB is deeply committed to open standards. Working with Davi, we've done sessions together, webinars together. I believe that you can kind of rely on the fact that MongoDB is committed to these open standards. Again, no inside information. I'm just kind of sharing with you my impression. We already talked about application layer, cross-cloud. This is coming up for us a lot. I don't know why, but people just don't want to be locked into AWS or Azure or Google or you name your cloud. They want the flexibility to move. And for folks like us who've been around for a long time, technologies change, companies change. That flexibility is really important. And I think, so MongoDB has really done a good job of positioning customers, MongoDB customers, to make those moves, to make them in the cloud, and someday to make the decision to go on-premise, or to be on-premise and someday go to the cloud. So this is incredibly easy to do, and I think we'll see more of that as we go forward. Okay, just want to leave a couple minutes for questions here. We make key management evaluations incredibly easy. You can download our key manager, you can deploy it, you can work with our partners. You have full customer support. We'll walk you through getting key management active on MongoDB. Again, it's a very painless experience. Okay, just a couple of pages of resources here. I want you to have access to this, so it's on the presentation. Will be uploaded, and if you have any trouble finding this, let me know. So why don't, before we stop here, there's my email address. Whenever I speak, I make my email address available to people. If you have questions, even if you want to do some deep dives into cryptography or standards, please feel free to email me. Okay, questions. We have time for just a few. In the back there, sir.
So today, MongoDB announced KMS for Atlas. What's the difference between KMS and KMIP?
Okay. KMIP is an interface standard. KMS is Amazon's implementation of a multi-tenant shared encryption key management facility. So today, as we speak, Atlas does not support KMIP yet as an interface to key management. So if you're deploying and you want to encrypt, you can do that in Atlas. You're going to use Amazon's KMS facility. If you're in Azure, you're going to use Key Vault. If you're in Google Cloud, you're going to use Google's Key Manager. So my hope, and one of the things that we've been talking about while we're here, is to open up KMIP support in Atlas. And I think we'll probably get there. So. KMS does not support KMIP. It is a proprietary Amazon interface. That's true. Yes, sir.
You mentioned about the performance overhead, which is 20%. Unfortunately, it's a wide range. So do you have any observation on what type of data or scenarios tend towards 2 versus 20?
Yes. So the question is about performance. As you know, there are a lot of ways to implement MongoDB. You can do sharded, non-sharded, replication sets. You can use SSD. There's a lot of ways to deploy this. So the short answer is it varies. It can vary. If you're using standard disk technology, you can get slower performance than if you're using like SSD, flash, more modern, faster access. So I would refer you for a definitive kind of numbers to the MongoDB document, because they have one on performance, and they talk about the different ways you deploy MongoDB and the likely impacts of encryption. So I have a general notion about that, but I'd rather just point you right to the definitive source there.
So you mean to say this predominantly the medium of storage and not really the data, which is causing that difference?
It seems to me to be largely the storage, but also the architecture of how you're deploying MongoDB. So there are differences between sharded and non-sharded, for example. So, yeah, okay. Let's see. How am I doing on time? Am I going to get the hook here? 5 minutes, okay. Yes, sir. Right, go ahead.
How do you handle, or what's your thoughts on rotating keys?
Rotating keys, this is a little bit difficult with MongoDB. It's my understanding, and I actually got that question yesterday, and I want to get a little bit better answer from MongoDB. My understanding is I think you have to start an instance of MongoDB empty on a different key, and then copy. So I think that's how you rotate keys.
That's not really a great. That's not a rotation.
Yeah. You have to get behind me in terms of suggesting a better way to do this with MongoDB. I think they're aware of this particular issue. On the key manager, you can rotate the key encryption keys quite easily. That's just an option on the key manager. But I know you're talking about rotating the actual encrypted value. Yeah.
Practice to rotate
Yeah.
it,
Yeah. MongoDB is not alone in this. I mean, there are other databases we work with where basically decrypting and re-encrypting is required. So this is not. I'm not dissing MongoDB on that respect, but it's a challenge. You have to just be aware of that.
Okay.
Yeah. Let's go to the back there. Yes, sir.
What's the level of granularity? Is it at just a table level? Is it, can you do it across all tables that you instantiate? Is it, you said it's not down to the field yet?
It's not down to the field. It's encrypted. It's like transparent data encryption in SQL Server. If you work there, it's the whole database. It's the whole. You encrypt everything. So I think I mentioned this before, and again, no inside information here, but I think we'll probably get at some point to a field level option. I know a lot of people want that. Personally, I think one way to meet right to be forgotten is to encrypt an individual's data with their own key, perhaps even giving them control of their own key. This is kind of an interesting thought. And then to execute key encryption, which is an effective standard mechanism for zeroization of data. So I think someday field level encryption I think will be important, but we're not there with MongoDB.
Like a bring your own key type?
No, that's different. Bring your own key is being able to bring from an outside. But bring your own key really in the cloud platforms where you can do this really is a way to compensate for the fact that you can't run your own key manager in the cloud platforms, except we can. But I mean, if you run our stuff, it's your own key manager. But the cloud services are not. You do not have exclusive access there. But you can bring a key, but you're putting it under KMS support or Azure support. So a little bit different thought there. No, field level access would just associate either a region or different elements in the database, maybe a user or a person with a specific key. Kind of where I was going with that. One more. Okay. Oh, where are we? Here.
Somebody mentioned if you are rotating the keys, you mentioned saying you have to initiate the empty daily, and so in that situation, your primary is having different key, and your secondary could be having different keys. How about the ops log, which is transferring from primary to secondary? Does it recognize, or how does it work?
Yes, so the question is, hey, I rotate my key, and now I've got a different key on the primary, but I got a secondary replication set, and it's got the original key. Well, first off, when you create that new key that you're going to use when you rotate the key, that gets mirrored immediately to the other key manager. So this is why real-time key mirroring is really important. So if I'm going to rotate the key, I create a new key, I create an empty database, I put the new database under protection of the new key. When I created that new key, it went to the secondary key manager automatically. And now when I move the data over, I've got synchronization between our key managers. This can get complex because you can use different keys on different replication sets. Okay, you can.
So in that situation, if you have different keys for any IOs, whether it happens on primary or secondary, you have to read AWS instance or you cache the keys at primary level or secondary level.
Well, we cache keys, that's for sure. Every key management system does. But MongoDB manages the differences between, if there are different encryption implementations, it manages that migration of the data from the primary to the secondary, which may be under a different key. So I just want to leave it there. We can get in a little bit more detail, but I think MongoDB is it. So I'm getting the hook. Okay. You hackers out there, who found the key? Okay, so what we say in the security industry is hackers don't break encryption, they find the key. So somebody's got a key under their chair. Who might that be? Okay, you guys on the inside row here, check under your seats, see if you can find an envelope or something. Yeah. Hey, we got a winner. Okay, thank you all.